Hello everyone. This video is going to cover all you need to understand database sharding with consistent hashing. I'm first going to start with why exactly the consistent hashing is needed, and then I'm going to show you how exactly is it implemented. And then we are going to see exactly how the consistent hashing is going to help you when you use the concept of consistent hashing with the database sharding. So this concept of consistent hashing is very common, but the problem is it is not very well understood, and many times it is only touched at the surface level. So this video is going to be a bit detailed. So I request you to put all your focus in this particular video for next 15-20 minutes so that you can understand this fully. So let's quickly get started. The first thing which we should focus upon is the requirement. So the requirement is simple, that you have a storage where you need to store keys and values. So a request will come to your server and then you would be asked to store, can you store the key and the value to the database? That's the overall requirement. Now the important part is that the database or the storage could grow or shrink over time. It could happen that on day one, you need 5 database server. The next day you could need 10 database server. Then the next day you could need 3 database servers. So these could always happen, and you always need to optimize for the cost. So you cannot buy 10 database server and keep them alive for every day. You could do that. Of course, there is one such design choices, but the problem which we are going to solve is to optimize for the database server. That's the thing, that when you do not need a particular database server, then you remove it from the cluster. So let's say you have 3 servers and the load is less and all your data could be just stored in 2 servers. So you could move or migrate all the data which is stored in one of the servers to the other servers, and then you are free. Likewise, if the load is too much for all the servers, then you should be able to add one extra server, one extra database to the cluster, and some of the data from each of the servers should migrate to the new database server, so that all the database servers, they have some amount of leverage in terms of the storage. So that's the overall requirement, that whenever you add a new server, it should be able to take the load of the remaining servers. And whenever you remove a server, so its load should be shared equally, almost equally by the remaining servers. So how do we do that? So first of all, the approach which I'm going to talk about is a very simple one. And this is definitely not the one which is expected, but it is important so that we have a mind map, that from where we are starting and how we are proceeding further. So this simple approach is called as the Modulo approach. And this is something which we use it very often. Not in database, but in general, because it's very simple to think. So this is the overall architecture, and the architecture will pretty much look same for all the approaches which we are going to talk about, including the consistent hashing. So you have a web service with you, and the request will come to your server that, hey, can you put or get this particular key or value to my database server? So the key is important because you need the key to get the database server. The first thing you will do is to compute the hash of the key. You can take any of the hash algorithms, different sharding mechanisms, take different hashing algorithms. You could take whatever you want to, and then you take the modulus of the hash and you will get a value. So if you take modulus of 3, you will get 3 values, 3 possible values, 0, 1 and 2. Now you could have a configuration in your system, and this configuration could be a very small database. The number of rows will be equal to the number of servers you have. This means really small database. So the mapping will be 0 equal to server 0, 1 equal to server 1 and 2 equal to server 2. That's it. That's the only thing. And it will work fine for you for most of the cases. You insert a data with a particular modulus, and when the request comes, you get the data with the same modulus. The problem arises when the load on these servers increases over time. And because of that, you might have to add one extra server. Or the other way around, you might have to delete the server. The moment you do that, your modulus changes, because it's a very much hard-coded thing you have done in your system, that you need to take modulus. So the moment the modulus changes from modulus 3 to modulus 4, you might start getting the miss of the data. So if somebody requests, hey, can you give me the data which should have been there for server 1? So now the mapping might go to server 2 and you might start replying wrong information that, hey, this data is not available. So those problems could occur. And that's the overall problem here. So let me show you what I have done here is that I have taken a very simple example of 20 keys. So that if you have 20 keys with you, you could imagine what exactly is going on here. So I have taken 20 keys from 0 to 19. And the assumption I have taken here is, just for the sake of this video so that you can have a real mind map, that the hash of 1 will be 1 and hash of 2 will be 2. Assume it to be 1 here. So the hash of a number is a number itself. That's the assumption I have taken, so that I have some further explanation. I mean, I'll have the easier explanation overall. So when you had 3 servers, this is how the data is going to be stored for you. The hash of server 0 will be 0 and hash of key 0 equal to 0 and hash of key 7 equal to 7 and likewise. So key equal to 0 is going to be stored in server 0. Key equal to 1 is going to be stored in 1. So that's what I'm doing. I'm taking the modulus of 3. I get a value, and whatever value I get, I map that value to a particular server. So I compute the data and then put that value, that key and the value in that particular database server. The moment you change the modulus, so there will be a point of time when you add an extra server. So the moment you add an extra server, you will have to take the different modulus and you have to rebalance the database. So it might take 15 minutes, 20 minutes, whatever. There will be a time duration in which the rebalancing of the database will happen. That, hey, we are moving some data from one server to the other server because a new server is added. So that rebalancing will happen and that will take some time. So let's say it takes 10 minutes or whatever. So what will happen in that 10 minutes is that many of the keys will need to be recomputed. So the rebalancing service or any such thing will actually get one key at a time. It will recompute the hash and the modulus, and it will figure out the servers, what is the value of various keys and what is the server it is supposed to be. So these are the key values. If the before server is written here and the after server is written here, so wherever these before and after don't match, that rebalancing service will delete the data from the previous server and move it to the new server. So if you look into this approach, you will see that there are 16 keys which needs to be rebalanced because the models of 16 keys are not matching. So only first few, and there is one for 12 which are matching. All keys have to be rebalanced and migrated. And that's the problem. The whole intent should be that this number 16 should be as less as possible. And here it's quite high. Out of 20, you have to rebalance and move 16 keys. So for 16 keys, you have to delete the record in a particular server and then add a record in the other server. This is not a good approach, and we'll try to see what are the other better approaches to do that. So the better approach, now this is not the final solution, but this will again be the base of the actual solution overall. So this is called as the simple consistent hashing. So it is important to understand this concept. The funda of simple consistent hashing is very simple. That is, it is nothing but a range based mapping. So you have a mapping of the ranges that if the hash is between 0 to 7, then you map to server 0. If you have a hash between 7 to 14, then you map to server 1. And if you have hash between 14 to 19, then you map to server 2. So basically what you do is whenever a request comes, you take a hash, and let's say your hash is somewhere here. Then you assign server 1. If your hash is somewhere here, you assign server 2. And if your hash is somewhere here, you assign server 0. We are going to talk about the mathematical part and stuff, but that's the overall idea. So here the hash for the key, if it is 12, then it will be inserted to server 1. Now, let's see what will happen whenever a extra load comes and you have to add one extra node to the cluster. So in those cases, let's say you added one extra server called as server 3. So you will assign sub range of the existing ranges, whatever you had. So you had a range, a very large range assigned to server 0, a range assigned to server 1, a range assigned to server 2. So what you did was that you took a sub range of the ranges, one of the ranges, and you assigned a particular server. So what will happen is that here you said that from 0 to 3 will be assigned to a new server, server 3, but other nodes will still remain unchanged. So here other servers don't have to change anything. And all the rebalancing will happen only for server 0 because you are just taking a subsection or sub range of the server 0 range. So the moment you do that, the moment you added a new server called as server 3, what you have to do is you just need to recompute the keys again in the rebalancing step. It will take around 15 minutes or whatever. You will get all the keys, you will recompute the hash. And if the hash says that the server should be server 3 now, then only thing you need to do is to remove that key from server 0 and insert that key to server 3. So that rebalancing will be done only for server 0. And here, based on those fundamentals, if you see the ranges I have assigned, so the ranges for key 0 to 7 are 0, the server 0. And from 8 to 14 is server 1 and 15 to 19 was server 2. The moment server 4 got added, so only the only range which got modified was from 0 to 3 inclusive. Other things were same, other things were untouched. So only 4 keys had to be rebalanced here. So that's a plus part. So that's one thing we achieved. So from 16 keys that had to be rebalanced, we are now having only 4 keys. But there is a big problem. And I think it is very much evident as well that now you have not given any relaxation to server 2 and server 1. Server 2 and server 1 are still suffering with their 80% CPU usage or 80% of disk usage, etc. You added one server, but the only thing you did good was that you rebalanced for server 0. So now server 0 is very happy. It might even have the disk usage of 20% now because a lot of their data got moved. But other servers are still suffering. So that's the overall problem in this approach, that you are assigning a sub range for the given server and that is not solving the problem for the other servers. Otherwise, what you'll have to do, you have to buy 3 more servers so that the server 4 could take the node of server 2 and server 5 could take the node of server 1. That is not a good approach, that you needed just one server, but you are ending up buying 3 servers. So that's the problem here, that you solved the number of free balances, but you didn't actually solve the problem because the loads are still there. So the same thing happens for the deletion as well. So let's say you had 3 servers and now instead of 3 servers, you just need 2 servers. So let's say you had to delete the server number 2, which is the one mentioned in purple here. So the moment you do that, you assign that range to one of the servers. So that's what you do. I'm still not talking in terms of the formulas and stuff, but we'll see those things later. So you just assign that range to one of the servers. So here the server 0 got assigned a very large range now. So in case of deletion, because you don't actually delete the whole servers. Why do we need deletion is because initially you had 3 servers and now the requirement is only of 2 servers because there is not much of this usage, etc. So it's not that by deletion, I'll delete the data. If you delete the data, it is just gone. So you're not going to delete the data, but you are just, first of all, going to rebalance all the data from the server where you are going to, which you are going to remove, and then assign those keys to the existing ones. So that's the thing that, whatever data server 2 had, you will move some of the data to server 0 and some of the data to server 1. But this approach says that, hey, I'll assign all the values to the one of the servers. So here, the yellow one got so large. So that's the problem here, that in case of deletion as well, the yellow server, that is server 0, might start to suffer. It would have been better if half of the load were shared by server 2 and half of the load were shared by, yellow one. So half would have been best, but that's not happening here. So both in case of addition and deletion, one of the servers is suffering or one of the servers is happy. So that's the problem in case of the simple consistent hashing. So this is the problem which we should be very clear that the number of rebalances have been optimized now, but now the problem is server load is not equally distributed. So in case of addition, if there are 3 existing servers and you had to add one more server, so the rebalancing is not unique, not equal. And likewise for the case of deletion as well, if there are, you need to delete a node, then all the data of the node which is getting deleted is just getting assigned to one server. So that one server is suffering. Ideally it should have been that if there are 100 keys existing in the server which you are planning to remove, so 50 should go to one and 50 should go to the other. But that is not happening, and that is a bigger problem. And likewise for the addition, that there are 3 existing server and you add one more server, and for those 3 servers, let's say 90 keys will need to be rebalanced, and ideally 30 should come from each server. Not that from one server you take 90 and other servers are just free. So now we know that this approach is not the best one, but it is important for us to understand the algorithm overall of what we have talked till now. So what happens here? That before even the request coming to you, you assign the range for each of the shards. That's the first thing you do. I have made it in a colorful way that you assign from 0 to 7 to one of the shard, from 7 to 14 to other shard, and 14 to 20 to the another shard. So that's what you do. But how exactly it looks like? It looks like in the form of, let's say, array. So it could be an array of 0, 7, 14, 20. So all the points where the one shard ends and the other shard starts. And whenever a request comes to you, let's say hash of the request is 12, you try to figure out where this 12, in which of the ranges this 12 belongs to. You could even have a linear search here. And it's a very simple problem statement that first of all, you do binary search and you will figure out that the 12 is between 7 and 14. So you do a binary search and you figure out which server my request belongs to. And you can have one of the notions. So you could take that 14 is inclusive or not. So the lower range to upper range. So upper range could be inclusive. So, this is how you could take the assumptions. That is up to you, that how you want to have a binary search and how you want to assign the values. So 12 belongs to this range. So you will insert or get the value 2/ from server 2. So that's how the code will look like, that you have a range assigned. It looks circular, but in the actual world, it will be an array or map. And you just have to do the binary search on that array so that you figure out a node. And once you figure out the node, then you can actually insert the values. So yeah, we understood the problem. That the problem is that the rebalancing is still not able to rebalance from all the servers. It just takes the rebalance from one of the servers. Now let's look into the solution which actually works. So here what we do is that we have a concept of virtual nodes. And how exactly it looks like, it's important to understand. So we still have this shard map database or the config. And here we have a little more information. So here you see what I have done is that I have a smaller chunks here. So instead of having 0 to 7, I have 0 to 2, 2 to 5, 5 to 7. Likewise, instead of having 7 to 15 or 14, whatever, I have even smaller pieces, 7 to 9, 9 to 11, 11 to 13, etc. So I have a smaller pieces, and then instead of assigning a one big chunk for one server, that is for server 0, I was assigning 7 contiguous blocks. I'm assigning smaller segments here. So what I do here is that I have server 0A, server 1A, server 2A. So 0A, 0B, 0C, they are just virtual names, and these names do not actually exist. I still have server 0 and server 1 and server 2. These are the actual machines which exist. For my hashing part, I just have the variables names as 0A, 0B, 0C, 1A, 1B, 1C, 2A, 2B, 2C, which correspond to server 1, server 2, and server 3. So they are called as the virtual nodes. They don't actually exist. They just exist for my calculation, so that whenever a request comes, in my array or hash map, I'll have such values. But if I get one of the three values, I'll assign server 0. If I get one of these three values, I'll assign server 1. And likewise for the server 2. So that's the idea. And both these mapping will be stored in my database. So that's the idea. And let's see how this works for you. So let's consider a case of shard addition. When a shard is added, and what happens then? So initially, let's say you had 3 servers, server 0, server 1, and server 2. So you initially had only 3 servers, and these are the ranges which were assigned. So from 0 to 2 assigned to server A, 2 to 5 assigned to 0 to 2 assigned to server 0, then 2 to 5 assigned to server 1, 5 to 7 assigned to server 2. So all these numbers you see which are being assigned here. So yellow is server 0. You can see yellow is here, then here, then here. Likewise blue, blue, and blue, and green, green, and green. So this is how it is assigned initially, and it was all working fine. Now you said that I want one more server because the load is getting too much. So what I do is that I assign the range of this server 3 randomly in this circle, and in a way that it takes up the load of the existing server equally. So what I have done here is that I have assigned the server 3 this block, that is a block number 2, block number 5, and block number 16. So these are the 3 blocks I assign. So and what I did was that I named it 3A, 3B, and 3C. So that's the advantage here. Instead of having a contiguous block, I could have a smaller blocks, and then those smaller blocks I could put in the array. So instead of having contiguous, I'm having the smaller blocks, and then I am putting those blocks here. So now there are just 3 movements needed. So that's the great thing, that all the server, let's say the green one, how many nodes it was containing? It was containing 1, 2, 3, 4, 5, 6. So 7. So there were 20 nodes. So they were 7 plus 7 plus 6. So this is the load which they initially had. So I needed 3 values. So I randomly took 3 values here. I could even take 4 values if I wanted to, because I could break the chunk. So that's the smart part here, that I could even take the values and I could assign the range whatever I wanted. And the range would be fine to store in the shard map database. So this will have a lesser number of movements overall. That's the great thing here. Now let's visualize the data even further. So you can see these are the hashes from 0 to 19. The server ID before were the ranges which are assigned using the colors here. And when I added a new server, so the only IDs or the only rebalancing that was needed to be done was for block 2, block 5, and block 16. That is, here if you see, these are the 3 rebalancing you needed to do, and the number of movements were 1 from each server. So the rebalancing was done in a way that the rebalancing is done from each of the server. It's not that you took all the load away from one server and the remaining server were just free. So that's a great thing here, that addition of this new server takes up the load equally from all the servers. So that's a great part. And that same thing happens for the deletion as well. So let's say you had initially 3 servers, 0, 1 and 2, and now you are planning to remove one server, that is the server 2. So here what we have done is that it will take some time for the server to be removed. It's not that the server will just vanish one fine day. So if the server has 50 nodes and you are planning to remove the server overall, so in that case, you would need to move those 50 keys to other servers. So the logic here to migrate those keys is that you migrate the key to the right or the clockwise direction of whatever server lies here. So for blue, for 16 and 17, you migrate the data to green server, that is, server 1. For 6 and 7, you migrate the data to yellow one, that is 8 and 9, that is server 0. And for this one, you migrate the data to green server, that is server 1. So you just have to recompute the data for all of these chunks and then see where that data should migrate. You have to migrate the data because if you are deleting a server, you have to migrate. But the migration now is done equally for all the servers. So the number of movements done is 6 because the node contains 6 node keys. So you had to do that. And the number of keys moved are 2 and 4. So it's not 0 and 6. It's still better. And if you do it more smartly, you might even reach 3 and 3. So at a large scale, it becomes almost same. So that's a great thing that the removal of the shards redistributes the data equally to the remaining shards. So yeah, that's the overall idea. I think this video was helpful for you. And if you see, this is the idea overall, that you have a shard map where you have the ranges assigned. Now the ranges are not contiguous, but a smaller pieces, so that your neighbors are different all the time. So that whenever you remove a node, the load get distributed to the different neighbors overall. So for example, if you remove the green one here, so the green's right neighbor is different for different places. So this helps you to distribute the load. So this one's load will be taken by yellow server, and this one will again be taken by the yellow server, but this one will be taken by the blue server. So that's the advantage. If you remove a node, your load will be distributed by the server right to you, and that's how you can distribute your load to the multiple servers. And likewise, when you add, you can add anywhere you want to, and you will take equal load from all the servers. So that's the overall idea, that you have virtual servers, but you have actual servers overall, and you have a mapping of virtual to the actual one. I hope this video was helpful for you. I will also put the GitHub link of the sample code of all the analysis which has been done, the binary search, and how the queries are being made and how the rebalancing is done. Do check out that code as well. And please comment if you find any of the sections which needs more clarity. I'll be happy to help. So that's all from my side for this video. Till the next time, bye.